Welcome to this overview of Model-Based Definition, or MBD. And this is a lecture-style presentation. There will be no demonstration in this video. So first off, let's talk about what is this thing called model-based definition. First, we'll take a look at its history. The first ASM meeting to discuss implementing model-based definition was over 20 years ago, back in 1997. And what happened was you had a number of different companies using computer-aided design software, and they started asking, hey, if we're creating these 3D solid models, why are we then going and creating 2D production drawings? What if we could eliminate the step of creating a 2D production drawing by putting all that information called PMI, or product and manufacturing information, in the model itself? And so then in 2003, ASME released Y14.41, Digital Product Definition Data Practices, which establishes how you can do this, how you can put that PMI, those 3D annotations, inside of a model. And the latest version at the time of creating this video is the 2019 version. And so in 2005, PTC in the Pro Engineer Wildfire 3.0 release introduced annotation elements, which supports these different 3D annotations as part of MBD. So the idea is that you are using the model as the source of truth. Rather than having a model and a drawing, hopefully you can just capture everything in the model itself. And it's a proven method to reduce the cost and time to market, and I'll talk about that on the next slide. Let's talk about what model-based definition is not. And a common misperception is that it means going completely without paper, going completely without drawings. That's not true. The idea is that you are, again, putting the information in the 3D model. That's what you're using to exchange with people. But in the situations when you need to have a drawing, you can create a drawing. And again, it's not a lack of documentation. It's that the documentation is in the 3D model. So what are the benefits of model-based definition? Well, NIST did a study a few years ago where they took a look at the cycle from design to manufacturing to inspection, and using models with MBD, with these 3D annotations, reduced that entire cycle by 78.4%. Imagine you're going into work on Monday and you're done your work on Monday. That's what MBD is like. All right, there's a lot of resistance to model-based definition. Let's talk about some of the common objections that people have. And so, big one I always hear, people say the drawing is the contract. Well, the drawing is only the contract because you say it's the contract. Why not make the model the contract? Also, there are other people who insist that you can't manufacture and inspect without a drawing. That's not true. There are machines for both manufacturing and inspection that are supporting semantic annotations. What that means is when you provide that 3D model with your annotations, your CMM machines for inspection and your CNC machines for manufacturing can actually read that PMI. I'm using way too many acronyms, can actually read the product and manufacturing information that are in the 3D model. Another objection, oh, we've always done drawings. And people are resistant to change. I understand change scares people, and once you say, hey, we're not going to be doing drawings anymore or as much anymore, they feel threatened. Well, we used to make drawings on drafting tables with electric erasers. We don't do that anymore. Companies change. And another one, hey, we can't share models with our partners. And I understand that. It's very scary if you're giving away your intellectual property in the model itself, but I'll talk about how you can use step files for that. All right, let's talk about some other different concerns that people have. And so Braun, the company, said that 70% of their user support is actually based around supporting drawings. And so that's a huge investment of time and effort for user support. So what if you could eliminate that support that the CAD administrators are having to do? They would have more time for implementing improvements to your CAD infrastructure. Another concern is that it is a culture shift. It's a huge culture shift, especially when people are used to making drawings. They've gotten good at creating drawings. Maybe their identity is based around being good at drawings. And so again, it's a big change to say, hey, we're not going to be making these 2D drawings anymore. We're not going to be doing drawings as much anymore, but instead, we're going to start putting this information in the 3D models. All right. Users have to model better because, hey, let's face it, in a drawing, you can override dimensions, which is a terrible, terrible practice. Sometimes to get around from doing things on the model, you can sketch lines and arcs and other different entities directly on the drawing. You can cheat on a drawing. But if you are making the model the source of truth, that means that people have to model correctly. They have to adhere to standards, and you have to train them in that, and you have to make sure that they are doing things properly. Another concern, can your manufacturer support MBD? There are a lot of manufacturers and vendors and suppliers that cannot support model-based definition today. And it also means that you're going to have computers on the shop floor. And I've actually been seeing this more and more. The last two companies that I worked at both had computers with big monitors on the shop floor so that people could access models directly in front of machines where they are working on building the products. Okay, so another concern, let's say that your manufacturer can't support model-based definition. And one thing I've seen happen is that you provide the models to the manufacturer and they just turn right around and create a drawing so that they can manufacture to it. So in other words, you're not really saving anything. You're just shifting the work, you're shifting the burden to the manufacturer. And one thing I'll mention later on is that it's really important to have conversations with your supply chain about implementing this because, again, you just don't want to push the work further downstream because you won't be seeing benefits in terms of schedule. All right, so again, a lot of people are reluctant about, oh, if we're putting this information in the models, now I have to give my models to my manufacturer. Hey, now they've got my intellectual property. They can use those different files in order to basically make my product, the stuff that we want to sell. And so there are protections around this using step AP242, which I will talk about. All right. Another thing that happens is that, okay, you create this model and the manufacturer takes a look at it and it has to make some changes to the model for sake of manufacturing. Maybe there's going to be a problem with the flow of material if it's being made from injection molding, and so they make some different tweaks to the geometry. So you have to make sure that there is a loop so that they can communicate this information back to you so that your CAD models that you own are correct. Also, what if there are times when you do need a hard copy? This actually happens. Well, again, you can make a drawing when you need to, and there are other ways of taking the outputs from model-based definition and putting it into a hard copy form. So those are all valid concerns here that you should consider. So let's talk about some of the things that you'll have to do to begin your journey for model-based definition. And the first step is probably setting up your infrastructure. So that means that you're going to have to set up your model templates, your part templates, and your assembly templates with combination states. And I'll talk more about what combination states are later on. Some other things is you might want to put some default annotation features already in the footer of your model tree. You might also want to set up some additional saved views that'll be used by the different combination states. You can use something called layer states. I'll be honest, I had a lot of trouble with layer states back in Creo Parametric 2.0, and I haven't used them since. Hopefully they have gotten better, but if you're using layer states, you'll want to have those in your part and assembly templates. Your standard notes. So the notes that you have appear on your drawings, hey, you're going to have those appear in a combination state in the model. And so you can set up your standard notes, the ones that always appear on your drawing. So for example, if you have an ITAR notice or a legal notice or proprietary notice, you want to set those up in your templates. And also the title block. So drawings have a title block. You can set up a title block in your part and assembly templates so you can list information about the name, the number, any other relevant information that you have. One last thing I want to mention is that people say, hey, okay, all this stuff in here, what kind of reference can I use to figure this out? And a great starting point is Mill Standard 31000. It's currently at revision A. If you do a Google search, you'll be able to find this on the internet and download it. They've got a great section in there about setting up the schema or the organization of your model templates in order to support model-based definition. If you take a look at the images inside of there, you'll notice that those images were actually created in Pro Engineer. A buddy of mine actually wrote that section, which I'll mention later on. All right, so let's talk about the general process for model-based definition. At the top of the screen here, you can see the ribbon for the Annotate tab. I've broken it up into two sections just so that it is a bit bigger to see. On the left, you can see that, hey, we've got the ability to create combination states. And combination states are a way of organizing all the different 3D annotations so you don't end up with a computer screen that looks like a bowl of spaghetti, or as other people call it, the floor of the barbershop, where you just have all these different annotations stacked on top of one another. And so on the left side of the ribbon, you can see where you can create new combination states. Of course, you can also do that from the View Manager. You might need to create annotation planes that have the correct orientation and viewing direction and text angle in order to create your different 3D annotations. And speaking of which, then you create your 3D annotations, and these include your dimensions, geometric tolerances, datum feature symbols, notes, surface finishes, and symbols. So once you have all those different 3D annotations, then you are going to organize them. So you can assign them to different combination states, remove them from combination states, and add them to annotation features just so that you can keep track of them, make everything nice and easily controlled. Okay, so let's talk about what combination states are. You access your combination states from the View Manager. There is an All tab, and on the All tab, it will list all the different combination states in your models. You can control whether a tab for that combination state appears at the bottom of the computer screen. You can also control, if you're using Windchill, whether that combination state is going to be published in your viewables, in your .pvz Creo view files. So in your combination states, you can see the setup dialog box down at the bottom. There are a number of different things that you can control in there. At the top, you have the ability to specify the orientation. In other words, what saved view is used by the combination state. You could also specify whether it uses a simplified representation, whether it's the master rep, automatic rep, or a custom rep. You can also apply style states, and style states are where you could have some components showing up as shaded, others transparent, others in hidden line, others in no hidden line, others in wireframe. So again, so people can visualize your products. You can also apply a cross-section in there. If it's an assembly, you could use an explode state. There are also appearance states, so you could have components in different colors in different combination states. So again, those are a great way of managing visibility, getting your people to pay attention to exactly what you want them to pay attention to in that combination state. Like I mentioned before, you can also have layer states in there if you wish. I currently don't use them. And the last thing that the combination state control is the visibility of annotations and any supplemental geometry, like any datum planes or axes that are used in conjunction with 3D annotations. If you don't have them controlled by the combination state, then you can use layers to manage the visibility of those annotations and what they call the supplemental geometry, any planes or axes that are associated with 3D annotations. All right, so let's talk about the different kinds of 3D annotations that you can have. You can have dimensions, and these can be either driving dimensions or they could be manually created. You could use ordinate dimensioning. Hey, any kinds of dimensions that you want to create, you can do that as 3D annotations. You also have your geometric tolerances, including your datum feature symbols. You can have notes, and those notes can either be flat to screen or they can be applied to one of your annotation planes, and you've got your different symbols and your surface finishes. And so after you generate your 3D annotations, some other things that you'll want to do is define the semantic references. I mentioned that you have machines that can read your 3D annotations. Well, you'll want to pick all the different surfaces that apply to a particular, say, geometric tolerance or a particular surface finish, so that when the machines are performing the inspection, they're able to understand what are the different references that go with that 3D annotation. Also, you're going to assign them to or remove them from different combination states to make them easily viewable. And some people like to use annotation features and have a separate annotation feature for every combination state. So you can take those different 3D annotations and assign them to annotation features. Be aware that if you have any driving dimension annotation elements, those cannot be assigned to annotation features. Driving dimensions are associated with whichever feature owns them, whichever feature they were created in. So protecting your intellectual property, you can do that by saving your different models out to the STEP AP242 format. You can do that by going to File, Save As, Save a Copy, and then choosing STEP as the kind of file that you want to use. AP stands for Application Protocol, and I forget when AP242 came out, but it was the combination of two other application protocols, one for like the automotive industry, the other one for aerospace, and it was specifically designed in order to support model-based definition. If you take a look at the dialog box on the left, you have the ability to include annotations and rich content when you are exporting your STEP files. And so again, that's how you're getting those 3D annotations to be available in the exported file. And using STEP is a great way of protecting most of your intellectual property, because people aren't going to have the model trees and they're not going to know the step-by-step process you use in order to create the model. And so again, I mentioned the important thing about the AP242 is that you can use those annotations, and also it'll have those semantic references that are used for inspecting by CMM machines, coordinate measuring machines that support model-based definition. So there is something called the model-based enterprise, and there are different steps towards getting to the top, level 6, where you are a fully model-based enterprise. And so everyone, it's like if you're taking your first step, you're starting out at level 0, you're probably still using drawings and you're drawing centric. So level 0 and level 1 are really driven by drawings. But then once you start to get to level 2 and 3, you're starting to get more model centric. And then once you get to like levels 4, 5, and 6, then you're getting model based. You are really using those models for your design definition for your manufacturing and for your inspection. And a big term, if you take a look at the top, there's that acronym TDP. That's called Technical Data Package. And so the TDP, that's where you're going to have your 3D model that you're going to provide to the manufacturer if you're doing external manufacturing. And it'll also contain other deliverables in there, like maybe your bills of material. Maybe you're going to have your notes controlled in a separate file. Maybe you're going to have your first article inspection sheets in there as well. So again, you're making everything digital. Just really, really speeds up the process. Okay, so again, people say, hey, we're doing model-based definition. We're putting all the product and manufacturing information into the model itself. What if I need a drawing? Well, the answer to that question, create a drawing. You can still create a drawing when you are using model-based definition. Drawings and model-based definition are not mutually exclusive. It's not one or the other. It's you're using your model as your primary source of information, but you're creating drawings as necessary. Just to give you a little bit of my situation that I had at a previous company. I started working in this company. On the first day, my boss said to me, my goal is to never create a drawing on this program. And we were able to do that for a long time until the point where we were having an external manufacturer do some composites for us. And for these composites, we had different tolerances in different areas, and there was just no way to capture that information in the 3D model. So we made a 2D drawing when we had to. So again, model-based definition is not drawingless. It's just a matter of you're not relying on the drawing. Another thing that companies are doing is that if they are using model-based definition, when they do have to make drawings, rather than doing the 100% dimensioned drawing, they're doing minimally dimensioned drawings. And so rather than having all the different basic dimensions on your drawing, well, the 3D model is the basic dimensions. And then the drawing, the 2D drawing, has any clarifying information, any other necessary information that's needed for the manufacture or the inspection of your products. And be aware that you can create a drawing view that uses a predefined combination state. There's that dialog box that comes open when it's like you start off a new drawing view and says, hey, do you want to use a combination state? I'll be honest, I almost never use one of my pre-existing combination states to start off a drawing view. I just tend to not have good luck with that method, but it's something you might want to try. Maybe your mileage may vary. And you can use the Show Model Annotations dialog box to show any of the 3D annotations from your model into your different drawing views. All right, so let's say that you are completely drawing centric and you want to get started on your journey to model-based definition to see some of the benefits that NIST has found in that report that they generated. Well, step number one, you're probably going to have to make some updates to your CAD infrastructure. There are a few configuration options that you might want to have turned on in your company-wide config.profiles, like display _combined _views. And there's some other different ones like what type of MBD you're using. And you can find out that information from the PTC spreadsheet with all the different configuration options. Another thing, like I mentioned, you're probably going to have to update your model templates to have those combination states and saved views and annotation features, depending on how you want your schema to be. The next step, you're going to have to train your users. And this is actually a lot easier than you think. Training the users, there's a class available in Precision LMS from PTC. I believe it's only 1 day long, but your users will pick up MBD practices pretty quickly, especially if they're already creating drawings. And third, you're going to want to have that talk with your supply chain. You're going to want to have that talk with your internal and external manufacturers. You'll want to talk with anyone internal that's doing final integration or assembly with your products to see if it's benefiting them, if they're actually going to be able to support this. And you might find out that, hey, we're not able to implement this because our manufacturers aren't ready. The other areas that you want to take a look at, again, a big one is inspection. You want to see if they can support inspecting using the Step 242s and the 3D annotations. And also you might need to make sure that your internal receiving is able to support it, especially if they are doing any kind of inspection before putting something into inventory. All right, let's talk about some resources that you can use for getting started in this. I do have a book on configuring Creo Parametric 7.0. Once a quarter, it is free to read for 5 days. I'm not just trying to get you to buy my book, although I'd greatly appreciate it if you did. And there's a lot of information in the book about setting up model templates, especially setting them up for model-based definition. I have a YouTube channel, which you might be aware of if you're watching this video right now, and I have an entire playlist on using model-based definition in Creo Parametric. As I mentioned on the previous slide, there is a training class in Precision LMS, and it is a great class. It is phenomenal. It'll teach you everything that you need to know for getting started with MBD to generating a technical data package. Also, you can get consulting. I provide consulting through TriStar, which is a value-added reseller. But let me throw some shouts out to some of my friends. First off, the foremost expert in model-based definition that I know is Mark Nielsen. He's got his own company called Tech Azul. Mark and I used to work at PTC together. Our desks were on opposite sides of the cubicle. Just a great guy, and he's so incredibly smart. If you want the expert on MBD, you want to talk to Mark. He's actually the person who wrote the training class for PTC's Precision LMS on model-based definition, and he also had a hand in that MIL standard 31000. And also to mention a couple other buddies of mine, there's a company, ITI, International Technic Group Incorporated, I think it is. I'm sorry if I got that wrong. A couple of my friends, Rafael Nascimento and Asa Trainer, they both work for ITI, and I know that they also provide consulting and implementation services in model-based definition. So there you have it. Hopefully that gives you a quick intro into model-based definition. I hope you enjoyed this video. For more information, please visit www.creowindchill.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button and ring the bell to be informed when new videos are uploaded. Thank you very much.